Hello. Hi, my name is Uwe Sauer. I'm a trained biologist. Systems biology is what I'm doing now. Um, I was for many years a member of the ERC panel for genomics and systems biology, and was also heading that panel for a round. I also am the president of a similar agency here in Switzerland, the ETH Research Commission, where we do interviews and we have research grants. So it's a very, very similar mindset. So I'm speaking from an experience of probably looking at hundreds, well, I know it's been many hundreds of these applications and the interviews that come with it. So I will try to give you a little bit of a view from the other side, because I think it's important to understand the process. And the first is, what is an ERC grant? I think you should almost forget the grant idea. This is not just a normal grant that you get. It's almost like a reward, not a reward for what you've done, but what you plan to do. And that's really important. This is not just a normal grant. This is just the very best and the most exciting and daring researchers that should get it. And that's also the mindset of us that are reviewing this. Okay, so your idea has to be out of the box. It shouldn't be something that also others are doing and maybe could be doing just as well. Somehow you have to make it clear, how is that could that be a breakthrough? It can fail, that's okay. The ERC is willing to take risks. It's not critical like the NIH, for example, in the US. They want you to almost have done half of the work. For the ERC, that is not necessary. We are willing to take risks. It has to be high risk, but of course doable in some way. Then if you have this mindset that you really wanted to try something big and original, who are the people that will look at it? And of course, there's two types of people. There will always be some external reviewers, because all these proposals are sent out to, typically we have 5, sometimes 8 external reviews. These will be experts from your area, all over the world. And they will look at some of the details. But the group that makes the decision is this ERC panel in a particular area. And this panel is typically composed of, I don't know, around 12 or so members from all different European countries. They're gender mixed, they are mixed in terms of their expertise. There might be computational people together with experimentalists. And they all are good scientists. And they all have the same goal. That's why they're at the ERC. They want to find in a huge number of applications the best ideas. And you can imagine it. I'm not sure how important soccer is in China, although I know it is in quite some way. But imagine you're the head of Barcelona and you're going to the middle school and you're looking for the starter grants, for the ones that have the highest potential. Of course, there are hundreds and thousands of kids, but you want to have the best ones, the ones that have the most potential. And so this is the mindset that we have. Not that we view you as kids, but we really look at the potential that someone has. We would like to see exactly what Anna said before, that in the pot of people that we collect afterwards, or the ones that we pull out of the pot, that there will be some that are at the level of a Nobel laureate. Not that we're looking for the Nobel laureates necessarily, but the potential. This is really important. That's the mindset that we have. And that's how we look at all of your proposals. Okay? So we're actually very nice people. We usually have a lot of fun. This is not a dark, sinister group of people that is sitting there with a butcher knife. We really have a very, very positive view on everything. But you have to help us that your proposal gets a chance. And that's what I wanted to talk to you a little bit about. And you need to understand what the process is. Of course, there's 2 levels. The first is when we get all the applications. This can be several hundreds in a given panel. That means that each one of us has to look at 20 to 30 proposals, something on this order, sometimes even more. And in this first round, we will all look at these proposals. We have some initial ranking and we all have our individual views. And then we go to Brussels, or at least when traveling was still possible. And we sit in a room for 2 or 3 days and discuss amongst us for every single proposal, where is it? And sometimes, you can imagine that someone has a different ranking matrix, that for someone the best is a little bit lower than for someone else. And so we discussed and we spent a lot of time to make a relative arrangement of the proposals. And the top ones are then invited for a second round. And since we are not experts on every single aspect in any of these panels, or in all of these panels, so we always ask for external reviewers. Okay, and so there's, when you write something, you have to keep in mind that you want to have something that's detailed enough for some colleagues that are really in your field. And at the same time, you need to be able to convincingly explain what the cool stuff is that you're doing and how you plan to do it to a broader group of scientists that will have to make the decision. Of course, we look back. At what the external reviewers say, and we are not overruling them. If they say this is not possible or this makes absolutely no sense or has been done 15 times before, then this very much lowers the chances. But we will interpret what the external reviewers say. Sometimes they say, oh, it's very important that there is already preliminary data of one type of another, and we try to make a judgment if that is maybe not absolutely necessary. So in this process, for the first round already, you have to understand that with 12, 15 people in the room that will all contribute, in the end, it is the group that makes the decision. It's not an individual. Your proposal will be handed to 2 or 3, it depends a little bit on the panel, of these internal members. They will read your proposal and they will also interpret what the external reviewers say. And then when we meet in Brussels, those 3, one of them will be sort of, we call this the lead reviewer. He will start or she will start and say, okay, this proposal is about this and this, and it is a breakthrough because of this. And it has high impact, it's beyond the state of the art, all of these things. And they will give their arguments. And then the other 2 reviewers come in, and then the whole panel will start to ask questions. But it's really important that you understand, you need to convince these 3 colleagues that are really reading it in detail, but you also have to provide them with the arguments, because they all ask the same questions. And one of the typical questions is, okay, why will this person be successful? Why is that so extraordinary? I'm just saying something that often happens, or why just another biomarker research? Or why just look at something that many others are already doing? You need to provide the arguments, because otherwise you have to rely on these panel reviewers to sort of find it somewhere in your proposal. Okay, so once the first round is over, we select the top percentage, typically I think 2 times as much as we can possibly fund. So this is already a very strict selection. And out of those, then you are invited to Brussels or these days, I actually don't know, because I'm not on the panel right now anymore. Probably now it is by Zoom. So you're invited to give a short presentation in front of the panel. At least this is for the starting and for the consolidators. This is where I was active. For the advanced, this is different. You give a short presentation, and then there will be 15-minute question and answers. And it's the same logic, but now it really goes into, now we need to probe how good your understanding is, how good your ideas are. And the most typical problems come that a proposal is too in the key points, not too specific. And I try to give you some examples. So if you are very strong on some experimental method in biology, this happens a lot, where young colleagues or applicants are very good with a particular technique. They work with this technique, and data come out, and one can imagine that something interesting comes out, but you don't really quite know. And then there is, at the end, there's a section that says, oh, and we're going to use computational methods, or to make it worse, we're going to use machine learning. And that's the end. And that's not a proposal. To just say, oh, we're going to use computational method, or we're going to integrate the data, that's just not a plan. You need to say how. Most proposals fail at the scientific feasibility because it's not clear how something could be done. And you need to explain a little bit how could these computational methods actually be used. The same is true when you just say, I'm going to use this technique. Some cool microscopy of some type, could be astrophysics, could be in biology, something in chemistry. But if you just say, I'm going to use this technique and then some miracle will happen and something cool comes out. The miracle is what we don't believe. You need to sort of show us a way, at least a plan of a way, and how specifically you could learn. What would you need to see in the data to find something really interesting? And how would you then know it is interesting? How would you know you're actually successful? So these are the kind of questions that we are dealing with. And these are the most important decision factors when it comes to the actual scientific feasibility. Because there's two parts. The first part is really, is it breakthrough enough? Is it out of the box? Is it high risk enough? Many proposals are. But then they also need to be scientifically feasible. And we discuss this a lot. We take a lot of time and we try to even take the benefit of doubt. If someone is very young, for example, a starting grant, we don't expect starting grant applicants to have demonstrated everything already. We're very willing to give benefit of doubt. But we give the benefit of doubt to someone who is able to show us already a little bit how would that possibly work. We believe you that if you're the master of some, let's say, microscopy technique, that you can do it. What we want to hear from you is, what in these microscopic images are you going to use afterwards to do what? And then how are you going to prove, maybe it's a mechanism, a new drug, whatever it is that you're interested in. Okay, so I think I actually want to stop here because we're a little bit over time already, and we can then, you can ask me now. Well, I think we just go on with the next person and then we ask questions afterwards. But it's the message I wanted to leave with you. You have to think big. This is not just an application that you just try. This is very selective, not just, but selective for potential in you. We want the new stars of the next generations. And I think you should be, if you start writing it, you should already be proud of yourself. That you're daring to write something like this, that's the right mindset. I hope you have now an understanding that the group of people that looks at this are very positive thinking scientists that come in general from your area, and they want the best. They're almost, well, I don't want to say we're like parents, but we want to find the best in a group. Look at this as trainers, but we have to make a selection before we assemble our team. That's what we're trying to do. And I hope I've been able to show you a little bit how the process works so that you can anticipate a bit on how to write this. And I think that's it from my side.